This short video hopefully serves as a review as to the different types of chemical bonds, why atoms form bonds, and a little bit of an introduction to some of the polyatomic ions. Remember that atoms bond in order to have a full valence shell. In this case, it's governed by something called the octet rule, which says that atoms have a full valence shell when their valence shell contains 8 valence electrons. This is true for most atoms, but there are about 5 atoms that don't follow the octet rule. And they're really the first 5 on the periodic table. They're hydrogen, helium, lithium, beryllium, and boron. Their valence shell actually is the first energy level, and because the first energy level is full with 2 valence electrons, they often are full with these 2 electrons. Of these elements, hydrogen is the one you really need to know because it does it the most. So there are a couple ways that atoms can get a full valence shell, and we'll talk about this first, but let's consider the following elements. The 4 elements here are sodium, magnesium, sulfur, and chlorine. Their atomic numbers are below, which is how many electrons they have. And if we're going to draw the Bohr model of these 4 elements, it's going to look like this. So if we go across left to right, all of these have their valence electrons in the 3rd energy level. But sodium has 1 valence electron, magnesium has 2 valence electrons, sulfur has 6 valence electrons, and chlorine has 7 valence electrons. In order to get a full shell, we'll start with sodium. It can do 2 things. It could either lose 1 or it could gain 7. Since it's easier to lose 1 than to gain 7, it's going to lose this electron and it's going to make an ion that's a +1 charge. Magnesium has the same option. It could either lose 2 or gain 6. In this case, it's easier to lose 2 than gain 6, so it's going to lose these 2 electrons and make a +2 ion. On the other side of the coin, you have sulfur, which has 6 valence electrons. This time, it could either lose 6 or gain 2. It's easier to gain 2 than it is to lose 6. So it's going to gain 2 electrons, and it's going to form a -2 ion. You can get the picture here with chlorine. Chlorine is either going to lose 7 or gain 1. And when it gains 1, it's going to gain it right here, and it's going to make a -1 ion. And the same thing holds true because remember the periodic table tells you which column it's in, how many valence electrons it has. That's how elements get full. They can either gain or lose electrons. Once they gain or lose electrons, though, you'll notice that elements on the left side of the table form positive ions, and elements on the right side of the table form negative ions. So we have some basic rules, and these are as follows. Metals are on the left side of the table. They have 3 or fewer valence electrons. They'll lose electrons to form positive cations. Nonmetals have 5 or more valence electrons. They'll gain electrons and they'll form negative anions. What happens is there's a type of bond where these positive cations are attracted to these negative anions, and they join together because of their opposite charges. We call this an ionic bond. 2 nonmetals, on the other hand, can't lose electrons. They really both want to gain. So instead of losing or gaining, they share electrons, and they form a covalent bond. So what this really tells us is bond type is determined by how badly the atoms in the bond want to gain electrons, and is governed by something called electronegativity. Really what determines bond type is this thing called electronegativity, which is a measure of how much an atom wants to gain an electron. If the electronegativity difference between the 2 atoms in the bond is greater than about 2, the bond is ionic. If it's between, say, 0.4 and 1.9, the bond is what we call polar covalent. And if it's less than 0.4, we say the bond is nonpolar covalent, and we'll talk about these later. The easier way to remember this is to remember the following. Ionic bonds happen between the following, and there's quite a bit in this list. A metal and a nonmetal, I'm going to say Nm for nonmetal, a metal and a negative polyatomic ion, a positive polyatomic ion, there's only one, it's ammonium, and a nonmetal, and finally between two polyatomic ions. A covalent bond occurs between two or more nonmetals, and that's it. So really, you got to look at the atoms, and if you see two or more nonmetals and no polyatomic ions, it's covalent. Everything else is ionic. So I mentioned previously polyatomic ions. Remember, polyatomic ions are two or more nonmetal atoms that are covalently bonded in a manner that holds a charge. And there are 6 polyatomic ions you need to know. They are OH-, which is hydroxide, NO3-, which is nitrate, CO3 2- carbonate, SO4 2-, which is sulfate, PO4 3-, which is phosphate, and NH4+, the only positive polyatomic ion, and that's ammonium. So this is the kind of problem I expect you to be able to solve from today. Recognize the following compounds and whether they're ionic, covalent, or ionic with covalent bonds. So we'll start with CO2. We look at our periodic table. C is to the right of the staircase. It's a nonmetal. O is also nonmetal. 2 nonmetals, always covalent. Second one, Ca is a metal. Therefore, it's going to be ionic. The question is whether or not it has covalent bonds. Cl is a nonmetal. It's not a polyatomic ion. Therefore, there's no covalent bonds. It's just ionic. Let's look at the third one. Na is a metal. Therefore, it is automatically going to be ionic. So we have to look at the rest of the element. There's a CO3. That's a polyatomic ion. It's carbonate. This is sodium carbonate. Therefore, it has both ionic and covalent bonds. Finally, the last one is a tricky one. It's N, H, and I. These are all nonmetals. However, you need to recognize that NH4 right here is a polyatomic ion, ammonium. And because of that, it's an ionic compound, and therefore it's a polyatomic ion, so it also has both covalent and ionic bonds. And that's it. Good luck.